On to a couple of calculations with angular kinematics. Before we jump into this first one, let's talk briefly about units. So we have our different quantities, our angular position, velocity, and acceleration. Now, angular position is an angle, so that can be measured in degrees or it can be measured in radians. And most of the time you'll want to use radians, which means that omega is going to be radians per second and alpha is going to be radians per second squared. In fact, those relationships that convert between linear and rotational quantities like L equals R theta, those are only true if you have theta measured in radians. They do not work when theta is measured in degrees. So up until this point, most of our angles we looked at were measured in degrees, but when we're looking at rotation rates, we want to do radians per second. Now we have another complication that we have to deal with, and that's that our rotation rates will often be given in RPM, which stands for revolutions per minute. So how do we convert 7,200 revolutions per minute to radians per second? Well, this is technically a frequency. The frequency of this would be 7,200 RPM. So I'll write it as revolutions per minute. Now I want to get that to be radians per second. So first of all, we'll convert this from minutes to seconds. So we're going to have minutes on top, seconds on the bottom. In 1 minute there are 60 seconds. So this gives us 120 revolutions per second. Now this again is F, not omega. So how do I get revolutions to radians? Well, if I multiply by 2 pi radians in 1 revolution, then this will work out to be 754 radians per second. So that is actually the answer to our problem here. And in general, if you want to convert frequency to radians, frequency to omega, to the angular velocity, you just multiply by a factor of 2 pi. You could have omega in minutes, but usually we want it in seconds because that's what we like to deal with. Oh, I forgot my squareds there. All right, one more problem here. Here we've got a carousel spinning around starting at rest. It accelerates for a little while, and we want to find the magnitude of a bunch of quantities. So angular velocity, just like when we had kinematic equations, you want to list all the stuff you know and what you don't know and what you're looking for. So the usual suspects are velocity, initial velocity, acceleration, time, and I ran out of room, but we also have displacement. In this case, the things I know are the initial velocity is 0. I'm given the acceleration is 0.06 radians per second squared. I'm given that time is 8 seconds, and I want to find the angular velocity, so that's this guy, and this one here I don't even care about. So then I'm going to go look for one of those kinematic equations that's going to help make my life easier. The one that relates all of these things and doesn't have delta x is just omega equals omega naught plus alpha times time. So this is 0 plus alpha 0.06 times 8. Pretty simple, straightforward calculation. You get 0.48 radians per second. Next part here, we want to find the linear velocity of a child 2.5 meters from the center. So if we remember our conversion to get linear quantities, we just need to multiply the angular quantities times r. So we're given r, and we found omega in part A, so all we have to do is multiply those two things, and we get 1.2 meters per second. Now to the tangential acceleration of the child, which is also a linear quantity, which we can get just by multiplying the angular quantity by r once again. So r is going to be 2.5, the angular quantity is 0.06, which gives us 0.15 meters per second squared. Then we want the centripetal acceleration. Now this is changing, but we want it just at that specific time, t equals 8, and so we know the velocity at that time. We could do v squared over r, but just for fun, let's do omega squared times r. Our omega is 0.48. We're going to square that, multiply it by our r of 2.5, and we get 0.576 meters per second squared. So this is one of the situations where we have both types of acceleration, centripetal and tangential. So if we want to find the total, we need to add those two things together. And we're going to do the square root of the sum of the squares, so 0.15 squared plus 0.576 squared, square root that whole thing, and we will get 0.595 meters per second squared. Okay, that's all. See you next time.